let's have a look at question 5 in our workbook. So if we are given there, we've got that f of x is equal to negative x squared plus 4. So immediately we need to identify that as a parabola. And I can see that because my x is being squared. And then we've got g of x, which looks like a straight line. 2x plus 4. So it takes on the form y is equal to mx plus c. So they are giving us those two functions. And then they ask us to sketch it. We need to sketch f of x and g of x on the same set of axes. All right, where shall we start? Let's start with the straight line. So if we're going to start with g of x, which is 2x plus 4, we need to know that that already gives us our y-intercept. So we're going to go plot it. Our y-intercept is by 1, 2, 3, 4. It's there. So we know that it's going to cut the y-axis there. And then remember, we can't look at that 2 and just go plot it somewhere. That is our gradient. Okay, let's go find the x-intercept. So then we've got the y-intercept and we've got the x-intercept, and then we can draw our straight line. So how do we find our x-intercept? We're going to make y 0. Y equal to 0. Okay, when we do that, when we make y equal to 0, we're going to be able to solve our x. So that would be 2x, and take that one over. We are just solving an equation, and then x is equal to negative 2. So what did we just find? We just found that when our y is 0, our x will be negative 2. So that is our x-intercept by negative 2. And there we've got those 2 points. So let's go draw that straight line. If we connect those dots. All right, let me just... Okay, so there we got the g of x. If we look at f of x, our parabola, we've got negative x squared plus 4. We need to know that this gives us our y-intercept, which is also our turning point. And that tells us that it will be a sad face, but we will also have to go get our x-intercept so that we can plot those points and draw our curve. So let's go plot that. It's also by plus 4, so the parabola's turning point will also be there. And we've got a sad face. So again, to find our x-intercept, even for the parabola, we're going to make our y 0. So 0 is equal to negative x squared plus 4. However you decide to solve that, I'm just going to take that one over, and then I am going to get the square root on both sides. Therefore, my x will be equal to plus or minus 2. And there are 2 x-intercepts. So again, they share those same intercepts. So by negative 2 and positive 2. And let's quickly go draw that curve. All right, there's my attempt. I hope yours looks a lot better than mine. I'm sorry about that. I'm trying my best writing on the computer, and that is not good. Sorry. All right, there's our parabola, and now I'm going to go put in all those coordinates, as you should as well. So that would be the points 0 and 4, and then we put in our x-intercepts. That would be 2 and 0, and this would be negative 2 and 0. There we go. So there we've got the curve of f of x. Done and dusted. So let's just quickly recap. We plotted the y-intercept for both graphs. We plotted the x-intercepts for both graphs. And there we go. Now we're going to answer some questions about these graphs. So I think what I'm going to do is I'm going to move these questions up there, that we can have it close to the graph. Okay. Use the graph, that's so important, to solve for x, where f of x and g of x is equal to each other. Now, why am I saying it's very important that we're using the graph? We're not going to work that out algebraically. We are not going to take, let me show you, we are not going to take the equation of the straight line and make it equal to the equation of the parabola. If we were meant to calculate that algebraically, that is what we would have done. But they say that we need to use the graph. So in other words, we need to know what that means, where they are equal to each other. It's the points of intersection. It is where these two curves cut each other. They cut there and they cut there. Do they cut anywhere else? No. Those are the two places where they cut. And they say that we need to solve for that x. So they cut each other where x is equal to -2 and where x is equal to 0. That is where they cut. Those are the x values where they cut. If they asked us to write down the coordinates of where they cut, we would have done that. All right, now with the next questions. We need to make sense of those. Students normally don't like them, but you just need to tackle them, don't avoid them, and get used to them. So it says, track with me. It says that f of x times g of x is bigger than 0. Now, I agree with you. When we just see that and we're like, what on earth does that even mean? Okay, let's break it down. If they say that f of x times g of x is bigger than 0, let's put that in words. So that means the y values of f. So in other words, the y values of the parabola, I'm just using abbreviations, multiplied with g of x, that's the y, multiplied by the y values of the straight line must be bigger than 0. So if I take the y value of the parabola times the y value of the straight line, it must give me, bigger than 0, it must give me a positive. All right? So if I take the y value of my parabola, wherever that is, oh, that's not going to work. If I take the y value of my parabola and I multiply it by the y value of the straight line, it must give me a positive. So what are we supposed to look at on the graph? Well, if we multiply two things, what gives us a positive? If the y value of the parabola is positive, and I multiply that with the y values of the straight line that is positive, that would give me a positive outcome. So both graphs needs to have positive y values. But there's another option. Both graphs can also have a negative y value, because if I take negative y values and I multiply that with more negative values, that is also going to give me a positive. They are our basic integers. So we need to go to the graph and we need to highlight. We need to highlight, let me just choose a nice color. So we're going to go to the graph and we're going to highlight on the graph where are both graphs y values positive, and then we're also going to highlight where both graphs y values are negative. Okay, so if I look at this part of the curve, there my y values are negative for the parabola, for the straight line. And the values for the hyperbola, there's not even an hyperbola on there. The y values for the parabola is also negative. So both are negative. So say our y value over there is -1, and our y value over there is like -1, 2, 3, -4. Both of those y values are negative. So if we multiply them together, it will give me a positive. All right, where else can we highlight? Where both are also positive. So if I think about that, there, my straight line is positive, my y values are positive, and my parabola's y values are also positive. So that must also be part of our solution. But let's also just quickly look at this. Over here, if we look at this section over here, there, my parabola has got a negative y value, while my straight line will have a positive value up there. Let me just go back to my orange. So what about this section over here? There my y values are positive for my parabola, while my y values are also positive for my straight line. So that must also be part of our solution, because remember, what are we looking for? We are looking for where both graphs are positive or where both graphs are negative. So it seems like the only place where it is changing is there where x is 2. At that point, from that point onward, my parabola has got negative y values, while the straight line has got positive. And we don't want that. The one can't have positive y values and the other one negative y values. So our answer over here would be, remember, we are solving for x where this is happening. So, okay, we can write this in different ways. We can say that x must be smaller than 2 for that to happen. We can also write it as x is an element of from negative infinity, and that's round brackets. Negative is, or infinity is never included. And then that must go up to 2. And in this case, I'm also not going to include my 2 because it wasn't included in the question, right? And there is our solution. So let's just quickly recap that idea again. So as we look like this, because we are trying to solve our x values, we look at the x and we go towards the graph. If this one is negative, and at that point the straight line will also be negative, then it's part of our solution. If we go, say, to that point over there, where x is negative 2-ish, then the parabola has got a negative value and the straight line has got a negative value. So it's part of our solution. If we go to this point over here, and where x is, well, minus a half or whatever that is, then this one has got a positive value and this one has got a positive value. So they both are positive. It will be part of our solution. And if we go to this side over here, my parabola has got a negative y value and my straight line will have a positive. So they are different. So that will not be part of our solution. Okay, let's head over to 5.3. For 5.3, it says that describe the transformation. So we need to describe it. Describe the transformations or the transformation of f. So that means the parabola. How is the parabola transforming to get to this one? So let's compare them. So for f of x, we've got negative x squared. So that is still the same. So our a value didn't change. So it is still a sad face. And it's not narrower or wider. But it changed from cutting the y-axis by +4 to cutting the y-axis by -6. So how would we describe that transformation? It's moving down, but by how many units? 1, 2, 3, 4 units. And then to get to -6, we need to move 6 more, or 6 units down more. Does that make sense? I think so. I think you know what I mean. 1, 2, 3, 4, 5, 6. So the new turning point would be there, and it would be a sad face. Let's describe that transformation. F of x moved down. How many units did we say? Is it 10 units? 10 units. Yes, how did we get to 10? Because it's 4 to get from there to there, and then it is 6 to get to -6. So that gives us 10 units altogether. Write down the equation of the reflection of f of x about the x-axis. What does that mean? I find that students sometimes just say, well, I had no idea what they were asking me. So if they are saying we need to get the reflection of f of x, so again, we need to reflect the parabola. Let me just get rid of some of these lines that are just too much and unnecessary. And then we'll get back to the question. When it says we need to reflect about the x-axis, then it means that the x-axis is our mirror that we are reflecting over. So if we are reflecting about the x-axis, it means that whatever is on this side of the x-axis is going to be reflected to this side of the x-axis. Okay, so we need to take f of x. So we need to take the parabola and we need to reflect it about the x-axis. So in other words, let me just get a different color that we haven't used. The point that is there will be reflected 1, 2, 3, 4 over the mirror. 1, 2, 3, 4 will be there. And obviously, I mean, those points are on the mirror, so they say exactly where they're at. And if it is then reflected, these arms that's there will now be reflected about the mirror, about the x-axis, and then be on that side. Okay, let's just go back to the question that they ask us to draw that in. No, they don't want us to go draw that in, even though we have got an idea more or less where it will be. Let me just go put that in. So we know that it will be more or less something like, oh my goodness, it's just going from bad to worse. So it must look something like that. But if it is reflected about the x-axis, then the reflection of that would be, I'm just going to call it t of x. So that is the reflected graph. Would be equal to, think about it, a sad face went to a happy face. So my a value needs to become positive. And my turning point that was by positive 4 will now be by negative 4. So in other words, happy face parabola with a coefficient of positive 1. And now the y-intercept will be by negative 4. We can also look at it like this and say that for f of x, every single y value that used to be positive, so every single y value that used to be positive will now be negative. That's just saying it in a different way. So that means that our f of x that looked like that needs to be multiplied by a negative, because this is my y, and my y's will be multiplied by a negative. Every value that was positive will now be negative. So it means that to find t of x, I need to take my f of x and I need to multiply it by a negative, which will give me positive x squared plus 4. So that's also something that you can remember. When it is reflected about the x-axis, every single y value that was positive will now be negative. So we're just multiplying that by a negative. And that's it.